All right, good evening. Thank you for the, and I hope that everyone is having a good meeting. Seeing the beautiful Girolando cows in the video that was showed a few minutes ago really makes me regret that I can't be with you in person at your meeting, but I hope in the future that we'll all be able to come together to learn from each other and to share ideas. What I'm going to talk about this evening is how we have used genetics and genomics to improve dairy cattle in the United States. And then I will also talk towards the end about some of the lessons we've learned and some of the challenges we've had to overcome. And some of these challenges are the same as some of the challenges you face improving the Girolando breed. So I hope we'll be able to have some things in common there. Okay, here we go. Okay, so so that we're all together in the ideas, I'm going to talk a little bit about why we want to improve our genetics, and then how do we actually do that? You know, what are the tools we need to make our cows and our bulls better? What are challenges we need to pay attention to? And then I will also, as I said, I'll talk about some of the things we've learned going through all of these steps. And okay, so here we go. I think that this is an idea that's familiar to everyone, but we face a lot of challenges around the world. And one of those large challenges is that we're going to have to produce more food as the population increases. And genetics is a great way to do this. And in particular, that's because improvements we make from genetics are permanent. Once you improve the genetics of your population, it doesn't go away. Sometimes if if you stop feeding the diet, that intervention goes away. Or if you stop using another tool on your farm, you lose the benefit of that. But genetics stays with us. And then obviously a healthy farm economy is good for the national economy. And this is certainly very true in Brazil, where so many people make their living working in agriculture, both in crops and in animals. And then as we increase the efficiency of production, whether it's crops or livestock, we reduce the impact we have on the environment and we improve our ability to feed everybody. Now, this chart shows prices paid to US dairy farmers for their milk from 2009 to 2018. I understand that the numbers are different. The absolute numbers are different in Brazil, but I think the same general truth is here. Nobody gets paid that much money for their milk. And so that means if you're going to be profitable producing milk and you're going to stay in business, you have to decrease the cost of producing milk. One of the ways you can decrease your costs is by having better cattle. So that's cattle that can produce more milk and more fat and more protein from less feed. They get sick less often, so you don't have to call the veterinarian, and they produce well even when it's hot or when it's rainy. And at the end of the day, good genetics actually lowers your cost of production. On this slide, again, I apologize. The numbers here are in US dollars, and the numbers might be a little bit different in Brazil. But the idea here, this is an example from the US. If two herds differ by $439, and this was a specific example from a real US Holstein herd, okay? The cows in the better herd, each of those cows will make almost $900 more net profit over the course of their lifetime. And that's just from having better genetics. Those cows are more fertile, so they get bred more easily. They need less semen. They're healthier, so you don't lose milk from the cow being sick. You don't have to pay for antibiotics. The cows give birth easily, so you don't have trouble with dystocia. And they also produce more fat, more protein, and more milk. And again, in the US situation, as an example, if the cost of producing 100 pounds of milk, that's about, about 4 kilos of milk is $18, then the herd that has the better genetics actually has a lower cost of production. And that means they can make a profit when the milk price goes down. So that's the important thing to remember here. If your genetics are better, you can get paid less money for your milk and still make a profit compared to people who don't have genetics as good as yours. But it's easy to say, improve your genetics, and that's not always as easy as it sounds. And in this case, why is that? Well, I'm a scientist, so we use the term phenotype, right? And all that really means is something that you measure. So say milk production, that's influenced by both the genetics of the cow and the environment that the cow was in. And the amount of control from genetics varies. It can be very high for something like milk production or a type traits, that is the size and the shape of the animal, and it can be very low for other traits like fertility and health. When the genetic control is low, that means environment has a lot of influence, and we can affect those traits by nutrition, by the way we manage our reproduction programs, by our housing practices. So even if you can't change the genetics quickly, there are other things you can do to improve the performance of your animals. But remember, as I said a few minutes ago, when you make genetic changes, those changes are permanent. When you make environmental changes, they're usually temporary. And so what is the value? Is there really value in improving the genetics? I keep telling you that genetics makes your cows better. Why should you believe me? Well, this graph is an example from the United States, and this is fat production in Holsteins. The yellow rectangle shows what the average production was in 1957. So that yellow bar represents what a Holstein cow would produce if there had been no change since 1957. You then see a red bar, and that shows you the improvements we've made from management. So for example, we feed cows much differently today than we fed them in 1957, and that's resulted in increases in production. And then the blue bar at the top of the figure shows you the gain that's attributable to genetics. And it's about 50-50. About half of the improvement is from better management, and about half of the improvement is genetics. But I would also remind everyone that if you put good genetics in a poor environment, that's not going to achieve what you hope to achieve. You have to have both a good environment and good genetics to get the largest possible gains. It's easy to forget that sometimes when geneticists like myself and my dear friend Marcos Vinicius will talk later. We always want you to focus on your genetics, but you also need to focus on the environment those genetics are in. And at the end of the day, it's important for all of us to remember, for myself and for my colleagues in the industry and for everyone, that it's the farmers who drive genetic improvement. It's you all who make the decisions about what bulls to use and how to manage your cows. And that's an important thing that's easily forgotten because the semen salesman doesn't make your genetics better. The scientists provide tools that can help you. The breeding companies provide tools that can help you, but it's your decisions that make things better. So that's why we want to help explain to everyone why genetics are important. And I know I talk a lot about the US because that's where I am. And we have a lot of variation in the US, just like you have in Brazil. On the left is a small farm in the US that's in the state of Pennsylvania, which is in the east, the northeast. And it's the cows spend time on pasture. They walk back to the milking parlor for milking, and they're also fed some silage. But then we also have the very large dairies that some of you think of, like North Florida Holsteins on the right, where they have thousands of animals and they send more than one tank every day to the milk processing plant. And genetics works for the small farmer, just like it works for the large farmer. You may have slightly different needs in your cows because of what we ask them to do, but genetics works for everyone, not just for the big guy or for the little guy. And I'm not going to ask you to I beg your pardon, I'm not going to explain every single box on this chart. What I want to show here in talking about where genetic evaluations come from is that there are a lot of people involved in the process and a lot of organizations. So first and foremost, the farmers record the data. That's the starting point for everything. And then there's the involvement of other organizations like the Girolando Association. So they have standards, they promote breeds. There's involvement from the Genetic Evaluation Center, from the milk testing laboratories. Lots of people are involved. That includes breeding companies, it includes breed societies, and it includes researchers. So genetics works. It's a good way to improve your cattle, but it is something that takes time, both to build the system and to make the improvements. That's what I'm trying to show you here. And in addition, when you start talking about genomic selection, right? So that's when we take the traditional pedigree and performance information that come from the farm, and then we combine that with knowledge about the DNA of individual animals. That adds a whole other group of organizations to the process. So the truth is nobody really can do this alone. We all have to work together to achieve these benefits. Now, I want to talk a little bit about the data. I've already mentioned that the data collected on your farms is where the genetic improvement process starts. So how are we doing in the US? Well, we're fortunate in the US because we've been recording information in some way since the end of the 19th century. Now, realistically, in our modern data era, we have data in the national database that goes back to about 1960. Some data goes back further. Some of the pedigree data, for example, goes back further. So in this case, we have about 75 million pedigree records. You can see that this slide's a little bit old because it says about 4 million genotypes, and we're closer to 5 million genotypes today. Millions of lactation records. We have even more daily data. We have reproduction events. So when a cow was bred, when she was diagnosed as pregnant, and when she gave birth. We also have several million health records. We have a lot of information about calving difficulty and stillbirth. And we put all of this information together to make predictions about the genetic merit of cows and bulls in the US. And, obviously this matters to you in the Girolando breed because of the Holstein component. So when we improve the genetics of the Holstein cow and the Holstein bulls, the Holstein breed, that can flow into the Girolando breed and help improve the quality of your animals as well. And then that goes back to the beginning of the discussion where we improve, your profitability and your efficiency. And this is just a very quick slide. I thought some of you might like to see. The photo on the left is what the US dairy records database looked like in the 1930s. And there were dozens of people who worked for the Department of Agriculture collecting the records and doing calculations. And now it's all replaced by the couple of computers you see on the right. So that's efficiency, I guess. We evaluate lots of traits in the US. I realize that you have a more limited data collection system currently in the Girolando breed, but in the US we started with only milk and fat. And you can see from this chart, from the years I put in, that we've added a lot of traits recently. But for example, for 52 years, the only traits we evaluated were milk and fat. And then we added the type traits, then that sort of opened the gates. Protein yield came in the late 70s, and then we've added a lot of new things recently. And I'm showing you this to give you hope. It's not good to say, wow, we don't have all of these things yet, so we can't make our cattle better. That's not true at all. You do the best you can with what you have, and you have an aspiration to collect new information. And the value of some of this information is going to be different in different places. It's going to differ by how you're paid for your milk. It's going to differ by how you care for your animals, how much it costs to have a veterinarian out, the rules about antibiotics. So the goal is not to make Brazil exactly like America. It's for us to learn lessons from each other that can help make the Girolando breed stronger. And I'm showing in this chart, this is simply showing you the first time we established a national selection goal is all the way over here on the left in 1971, and that included milk and fat, and that was the only thing in it. And you can see that as we've added more traits over time, we've added new things to our selection goal. But you can see, this has been a 50-year process. This has not been a 5 or a 10-year effort. And obviously genomics has changed things a lot. And I'm going to talk about why in the next couple of slides, but we're very fortunate in the US. In the very beginning, which is all the way over here at the left, it took all of the resources we could assemble in the US to get 1,500 genotypes together. Now we have millions. And this photo on the right is showing that's one collection of samples from one farm on one day. So this is obviously something that's been successful far beyond what we had hoped in the beginning. And I think that's a sign of hope as well in a smaller breed, because genomics gives us lots of information much earlier in life than we've had before. We were the largest database in the world. We've been passed up by the Ancestry and 23andMe folks, but for several years, the USDA was in the lead. So why do we care about these genotypes anyway? Well, when you look at a trait like fertility, right? It has a low heritability, maybe 4%. That means there's not a lot of genetic control. So information about the pedigree of that animal is worth only about $7 of records. For protein yield, I'm sorry, I think I made a mistake on my slide. This should say what's a genotype worth for production, because I'm talking about protein here. These numbers are correct. So for protein, the genotype is like adding an extra $30 without having to record anything in the field. It's a more dramatic difference for fertility, which has a low heritability compared to protein, so 4% versus 30%, and just having the genotype for a bull. One genotype for one bull is just like recording records in the field for $131. That means that we can make predictions early in the life of the animal that have a lot of accuracy. That means that we can increase the speed at which we're making changes in the population. And that's what this figure is showing. Around 2000, we were gaining $14 of profit a year from the national selection objective. That had gone up to about $40 by 2010, which was right at the beginning of genomic selection. And you can see that in the 5-year periods since then, it's increased to almost $70 and then almost $80. So that's an important aspect of genomics, is it lets us go faster than we could go without genomics. But it doesn't work for everybody, right? It works in cattle because it works for US dairy cattle because we had a large historical collection of information, right? We had records that went back to the 1960s. We had a well-developed genetic evaluation program. So we already had that system for doing PTAs in place. There's widespread use of artificial insemination in the United States, about 75%. And we had all these other things that go with it, progeny test programs. So we had bulls with high reliability. A cow is worth a lot of money relative to, say, a chicken or even an individual pig. So it's worth the cost of genotyping. And then we also have a long generation interval in cows. We can shorten that with genomic information, and that's what helps us go so much faster. And I'm watching the time. I'm not going to run over, I don't think. So, this has been great. We can go faster. We can make more profitable cows, but it's not free. We have to pay attention and watch out for danger spots. And one of those spots that we have to watch in the Holstein is the rate of inbreeding, right? We're going faster, but one of the consequences of genomic selection is that we're making more selection inside of families than we ever have before. So that means that with the really elite bulls, with the best bulls, they tend to have a high relationship to the breed, and we're making that go faster and faster every year. So in this figure, the red lines, for example, are showing the young bulls, and you can see in particular how the genomic inbreeding is going up for those animals. So nothing's free. If you go faster, you have to be a lot more careful about the matings you make and the families you pick, or it's hard to go back. Now, the challenge we face in the US is that there are some negative effects of inbreeding. So for example, if inbreeding goes up by 1% in the population, average milk production goes down by about 32 kilograms. However, today, we're increasing milk production through genetics by almost 60 kilograms a year. So right now we're getting the genetics are getting better faster than we're losing ground from inbreeding. But obviously this can't continue forever. So I encourage you to watch your pedigrees carefully and take that seriously. And the reason I encourage you to take that seriously is this figure shows a list of known recessives in the US Holstein population. Some of these things are not harmful, right? Red coat color is not harmful. Polled is not harmful. But we do have a number of genetic diseases that most of you are probably familiar with. And if one of these, if there's a disease we do not yet know about, and it occurs in a very popular bull, because we're going so fast with genomics, we can spread that around the population very quickly. And then we have to figure out how to limit our matings or remove animals from the population to deal with that situation. This is not limited to Holsteins. This is not limited to the United States. Every cattle breed in every country has genetic diseases, even if we don't know that they're out there in the population. So please don't tell yourself that, well, we don't have to worry about it because, Girolando's different. You're not exactly the same as Holsteins, but you have the same dangers here. And so to wrap up, I wanted to talk a little bit about some of the challenges and solutions we've dealt with in the US. And I've already talked about this some today. Data are needed to produce good evaluations. When I say good evaluations, I mean trustworthy evaluations. Okay. And the way we deal with that challenge is Both the farmers have to have an incentive to invest your time and your money in data collection, and so must the industry. And when I talk about recording data, it's important to emphasize it has to be data that everybody can trust. I mean, anybody can make up a number and write it down on a piece of paper, right? We've all seen that. So as we're building these systems, it's important to build a framework where things can be double checked, where there are clear processes, where there are standards and guidelines. If you make that investment of time and money, that's going to lead to dependable genetic evaluations that are going to help you improve your cattle, improve your population. Some traits have low heritabilities, right? We talked about that at the beginning. That means there's not a lot of genetic control. Well, the key there is we can use genomic information to help us get higher reliabilities on those traits early in life. We just talked about the risk, the challenge of inbreeding. In the US, we adjust a bull's evaluation. So if he's going to produce more inbreeding, his evaluation gets lowered. But that's sort of solving the problem after it's already an issue. The better way to deal with that problem is to be careful every day when you're making matings and when you're picking bulls. Sometimes using that number 5 bull or that number 6 bull in your herd is going to get you just as much benefit as using the number 1 bull or the number 2 bull, and you're helping to spread out risk in the population. And something that's becoming, in my opinion, that's becoming a bigger issue is in history, the genetic evaluations were produced by a national evaluation center, like in Brazil. It's run by Embrapa in collaboration with private companies. In the US, it was the US Department of Agriculture. Now many companies calculate their own evaluations, and they will use those to tell you, why you should buy their bulls. Many of those are good evaluations. They have good scientists doing that work. But we need to have some agreed upon international standards for genetic evaluations. And as I talked about in the first point, that there needs to be some sort of audit, whether it's from a breed association or from a ministry of the government, or there could be other structures. It could be a farmer-oriented system. But you should be skeptical when somebody tries to sell you a proprietary evaluation. You should make sure you understand what that number is based on, so you can understand if you're being sold something that's reasonable, or if someone's just trying to get you to spend your money. So in conclusion, recognizing that I'm a geneticist, I believe that genetic improvement is a very cost-effective way for improving productivity. Genetic gains are cumulative and permanent, but successful genetic improvement depends upon a constant flow of data. You can't collect information for a little while and then stop doing it. If you stop doing it, your system stops working. The number of traits that go into the selection objectives in many countries is growing, but it can be challenging to record the data in a cost-effective way. It's not very expensive to record milk production or fat yield. It's very expensive to record feed intake, as an example. And then we also want to keep an eye on genetic diversity in our populations to avoid long-term problems that can come from having too little diversity. So we use up the diversity in our population.